Today I will explain how to solve LPP problems using MATLAB. LPP is linear programming problem. A linear programming problem may be defined as a problem of maximizing or minimizing a linear function subject to linear constraints. The constraints may be equalities or inequalities. For example, you take this problem, find the numbers x1 and x2 that maximizing 2x1 plus 3x2 subject to the constraints x1 greater than or equal to 0, x2 greater than or equal to 0, and 3 less than or equal to constraints. In this problem, there are two unknowns and 5 constraints 1, 2, 3, 4, 5. These are conditions. X1 should be greater than or equal to 0, x2 should be greater than or equal to 0, x1 minus x2 less than or equal to 0, 3x1 plus 2x2 less than or equal to 42. If there is a small problem, 3x1 plus x2 less than or equal to 30. Okay. In this problem, there are two unknowns, x1 and x2, and 5 constraints. All the constraints are inequality constraints. All the constraints are less than or equal to, or greater than or equal to, inequality constraints. And also, all the constraints are linear. In this function, here we have to find out x1, x2, that maximizing 2x1 plus 3x2. 2x1 plus 3x2 is called objective function. These are unknown values x1, x2 that we have to determine. So this is an objective function. Objective function is linear. Constraints are also linear. That's why it is called linear programming problem. Okay. These two are x1 greater than or equal to 0, x2 greater than or equal to 0 are called non-negative constraints, and these are called main constraints. Here, the first two constraints are x1, x2 are special. Those are called non-negative constraints, and the other constraints are called main constraints. The function to be maximized or minimized is called objective function. Here, the objective function is 2x1 plus 3x2, maximizing 2x1 plus 3x2. So, how to solve this type of problems using MATLAB? There is a solver, LINPROG, L-I-N-P-R-O-G, LINPROG, linear programming solver, LINPROG, L-I-N-P-R-O-G. For example, the standard LPP problem will be like this: minimizing f subject to less than or equal to constraints, equality constraints, and as well as bounds, lower bounds and upper bounds. Here only in the previous problem only lower bounds are there. x1 greater than or equal to 0, x2 greater than or equal to 0, and only less than or equal to constraints are present in the problem. This problem is only less than or equal to constraints, and lower bounds are x1, x2. No upper bounds. There is no limit for upper bound. All are less than or equal to constraints. The previous problem. In the previous problem, there is no equality constraint. Okay. So what is the syntax? Syntax is linpro f a comma b. This is one syntax, and another one syntax is linpro f a comma b, a equalities, b equalities. Only inequality constraints are there, we take this one. Only if the problem contains inequality constraints and equality constraints, we take this one. If the problem contains equality constraints and inequality constraints, lower bounds and upper bounds, we take this one. Most of the time, we use this third one. Okay. One by one, I will explain. LinProg solves linear programming problems. X is equal to LinProg f a comma b solves minimization. If you want to solve LPP using MATLAB, the function should be minimized. Otherwise, suppose if it is maximum, we'll convert it to minimize and we'll solve. Linprobe f a comma b solves min objective function such that a into x is less than or equal to b. That means only less than or equal to constraints. Linprobe f a comma b comma a equalities b equality solves the problem while additionally satisfying the equality constraints. A equality of x is equal to b equality. Set A is empty, b is empty if no inequalities exists. No inequalities exists. So this one is linprobe f a comma b, a equalities b equalities LU, lower bounds, upper bound defines set of lower and upper bounds on the design variables x, so that the solution always in the range in between lower bound and upper bound. If no equality constraint, we set 0. We set empty. A equality is empty, B equality is empty. So if you take a problem, we can easily understand what is A equality. A equality is a matrix, B equality is a row matrix, A equality is a matrix, B equality is a row matrix. Everything I will explain with the problem. Suppose this is the problem. Suppose this. Solve the LPP using MATLAB. Find x such that minimizes. So no problem, no need to change anything. Minimizes f of x is equal to minus 5x1 minus 4x2 minus 6x3 subject to x1 minus x2 plus x3 less than or equal to 20. 3x1 plus 2x2 plus 4x3 is equal to 42. 3x1 plus 2x2 less than or equal to 30. Only equality constraints are there. Inequality constraints are there. And lower bounds. 0 is less than or equal to x1, 0 is less than or equal to x2, 0 is less than or equal to x3. First, we write in standard form. How to write it in standard form? This is the f. Our f is minus 5x1 minus 4x2 minus 6x3. That we have to write f transpose of x. What is x? X contains three variables x1, x2, x3. How to write this in f transpose? F transpose means minus 5 minus 4 minus 6 transpose x is the variable x1, x2, x3. x1, x2, x3. That is x1, x2. Then only it will be equation. Okay. x1, x2, x3. X. X is a x1, x2, x3. I'm not writing. This is nothing but this like this. We have to do like this. It is a row vector. We have to give it column vector. Minus 5. How to give a column vector? Minus 5, minus 4, minus 6. That is minus 5. Semicolon. Minus 4. Minus 6. Semicolon. Of x. That means x1 is x1, x2, x3. So this is minus 5, minus 4, minus 6 into x1, x2, x3. x1, x2, x first row in the second column plus this x1, x2, x3 like this. Okay, x. Yes. This is also by because I have to write constraints. Okay. Next, inequality constraints. How to write this one? This is good. 1. A equality sign writing. A inequality sign writing. 1 minus 1. 1. 3. 2. 4. 3. 2. 0. Of x, that is x1, x2, x3, and writing just x less than or equal to 20, 42, 30. This value we are mentioning like this. In the previous slide, this we write it as a x is less than or equal to b. That is the previous slide. Ax is less than or equal to b. This is the meaning of this one. Ax is less than or equal to b. Okay? Ax is less than or equal to b. Suppose if it has any greater than less than greater than or equal to, we convert it as a less than or equal to by multiplying minus. Suppose if it is greater than or equal to 30, it is that is minus 3x1 minus 2x2 less than or equal to minus 30. Like that will take. Okay. This problem contains minimizes ax is less than or equal to b with lower bounds. Am I correct? A equalities are not there. A into equalities, that is equality of x. Equality of x is equal to b equalities. Right hand side. Here A is null, B is null. There is no A matrix. There is no B matrix. Why? Because both are null. These are empty bases. A is null, B is also null. Why? Because there is no all are less than or equal to constraints. Inequality constraints. No equality constraints. This is lower bounds. 0 is less than or equal to 0. What is this one? How to write this one in terms of this matrix? Suppose if you take this one. x1, x2, 0, 0, 0, less than or equal to x1, x2, x3. Am I correct? This is nothing but 0, 0, 0. This null matrix is less than or equal to x1, x2, x3. That is x. Okay, this is the lower bound. Lower bound is 3 rows, 1 column. That is the meaning of this one. Lower bounds is less than or equal to x, less than or equal to lower bounds, upper bound. Lower bound, upper bounds. UB, yeah, not LB, LU, upper bounds. Okay, UB. Upper bounds are not there in this problem. Okay, only lower bounds are present. That is 0, 0, 0. That is 3 zeros and 1 comma. Zeros of 3 comma 1. This one. Now, this is the first step. We have to write in standard format. Then F transpose A, B, lower bounds, lower bound, zeros of 3 comma 1 or 0, 0, 0 later. 0 semicolon, 0 semicolon, 0. Not a problem. You can write like that. Okay. Here lower bounds are there. Capital A, capital B. We are taking this the layer solver. This solver. Being probe. Why? Because lower bounds are there. F, A, B, A equalities are not there, B equalities are not there, lower upper bounds are not there. So we are taking, we have taken this solver link probe. X F value is equal to lim pro F is the value A matrix B matrix. There is no equality constraint, null matrix, lower bounds, zeros. Upper bounds are not there. Any value you can take. Any value, that's why we are not mentioning anything. It is not an empty. Any upper bound, there is no constraint on the upper bound. Okay. If x1 is 0 is less than or x1 is less than or equal to 5. In that case, we have to mention. Suppose the constraint on x1 is 0 is less than or equal to x1 is less than or equal to 5. Constraint on x2 is equal to 0 is less than or equal to x2 is less than or equal to some 7. Third 0 is less than or equal to x3 is less than or equal to some 8. There we mention lower bounds and upper bounds. If we call this routine, this solver automatically will get the solution. Okay, so we'll try. First, we'll try with the MATLAB. F and minus 5 minus 5 semicolon minus 4 semicolon minus 6. F A matrix 1 minus 1 1 semicolon 3 2 4 semicolon 3 2 0. Next, right hand side B is equal to 20 42 FAB lower bounds will be. Two ways we can 0 semicolon 0 semicolon 0 0 semicolon 0 semicolon 0. Or otherwise this is zeros of zeros on top. Okay. My solution x f value function value and variable x is equal to intro. This is solver. Out what we are doing first f capital E B empty basis equal to null LB. Now the linear program is problem is solved. X1 is 0, X2 is solution is X1 0, X2 is 15, X3 is 3. That is the solution, and the function value, the minimum value is minus 78. Minimum value is minus 78. So the same problem we can solve in different way also. The same problem we can solve in different ways using linprog. Here, if you observe this problem, or if you observe this problem, here this value less than or equal to 0, this value less than or equal to 0, this value less than or equal to 0. These values also we can write less than or equal to 0. Am I correct or not? Minus x1 less than or equal to 0, minus x2 less than or equal to 0, minus x3 less than or equal to 0. Lower bounds also we can convert it as constraints. So in that case, the A will become like this. F is same, This A value I'm writing like this. This if you take less than the x1 less than minus x1 less than or equal to 0, minus x2 less than or equal to 0, minus x3 less than or equal to 0. This entire value we can write it as like this: 1 minus 1 1 3 2 3 2 4 3 2 0. Third equation minus x1 less than or equal to 0, minus 1 0 0 minus x2 less than or equal to 0, 0 minus 1 0 minus x3 less than or equal to 0, 0 0 minus 1. So the entire into entire value less than or equal to, what is the right hand side? 20 x is there, that is common. X x1 x2 x3 20 42 30 0 0 0 x1 x2 x3. This minus x1 is less than or equal to 0, minus x2 less than or equal to 0, minus x3 less than or equal to 0. So if we combine these two, we can write like this. Now in this case, only F is present, capital A is present, and small b is present. Am I correct or not? There is no equality constraint. The equality constraint is not there. Lower bounds are not there. Lower bounds also are treated as a inequality. F, A, B. Okay. Now I am taking. Now I will. F is already there. F is already there. A I am changing now. A, capital A is equal to 1 minus 1 1 semicolon 3 2 4 semicolon 3 2 0 semicolon minus 1 0 0 semicolon 0 minus 1 0 semicolon 0 0 minus 1. This is the matrix. Okay. Yeah. Okay. Now we have F F A. Next B. What is my B? 20 42 30. 20 20 42 30 0 semicolon 0 semicolon 0. F is there, capital A is there, small b is there. Okay, directly we can take x F is equal to ln log F capital V small. Okay, we got the same solution. Am I correct? This problem contains only objective function less than or equal to constraints. Objective function less than or equal to constraints. Inequality constraints. So I converted lower bounds also. I wrote lower bounds also as a inequality constraint. Okay. So there is a toolbox is available to solve all optimization problems. This is we are using solver, improve solver. There is an optimum toolbox. There is one of the powerful toolboxes in MATLAB. Optim toolbox, Optim tool. This is the optimum toolbox. There is no need to remember all the commands. Directly you have to enter the matrix and MATLAB, the toolbox will be the solution. Okay. Here, there are so many things are there. I will tell you about this one also. F solve. Yesterday we solved non-linear equations. Am I correct? F0 single non-linear equation. All are present here in this toolbox. This is 2007 version. So if you take latest version, so many things are available. So LinPro, I'm taking linear programming problem. You take a medium scale simplex method. Okay. So you enter a matrix F. There is no need to only F. F is what is F value here? Stating -4, -5, -4, -6. At enter -5, -4, -6. That's it. This is the objective function. What about linear inequalities? Here linear inequalities. At enter. Now I am entering this value. 1 minus 1, 1. 1 minus 1, 1 semicolon. Okay. 1 minus 1, 1. 3, 2, 4. 3, 2, 4 semicolon. 3, 2, 0 over right hand side B. B is, we should not give B is equal to here. Only B, matrix B, we have to enter matrix B. B is 20, 30 to 30, 20, 40 to 30, 20, 40 to 30, 20 semicolon, 42 semicolon. So there are no equal empty braces, we have to give here. Empty braces, the lower bounds, zeros of 3, 1, zeros of 3, 1. 3 rows, 1 column. If you have any doubts, you write down. By changing inequality to equality. What is it? Okay. So zeros of 3, 1 or otherwise you write down 0 semicolon 0 semicolon 0. No upper bounds. Okay. That's it. Hit enter and start. So -78. The solution is -78. Okay. Solution is -78. X first variable is 0. Second variable is 50. Third variable is 3. Okay. Here there is no need to remember syntax and all this. Only we should know how to enter values. Okay. Suppose if you enter like this. Suppose here I want to remove this as a null. This is also null. No need to write as null here. Here I will write it as -1, 0, 0, semicolon, 0, -1, 0, semicolon. First I will tell you here. First suppose if you put empty braces here, what will happen? Start. So there is no constraint here. Am I correct or not? There is no lower bound constraint. It has taken negative values also. It will take negative values. It has to, the value is like this. Okay. So there is no lower, I am not putting any constraint in the lower bound. So lower bound constraints, whenever we take an LPP, x1 greater than or equal to 0, x2 greater than or equal to 0, x3 greater than or equal to 0. So the lower bounds, we should be very careful. We have to mention the lower bounds. Okay, here I am taking like minus 1, 0, 0, semicolon, 0, minus 1, 0, semicolon, 0, 0, minus 1. Here minus 30, semicolon 0, semicolon 0, 0. Clear result. Oh, here empty. Clear result. Start. Inequalities. Any mistake? Balanced. Something is unbalanced. 1 minus 1 minus 1 0. These spaces are missing. Oh, double bracket. Start. Start. Okay. Here double bracket I put. So minus 78, 0, 15, 3. Okay. Like this, we can solve LPP. Suppose equality constraint, equality and inequality constraints are there. For example, I'm taking another problem. Another already explained this one. Another method to solve the LPP. This entire thing I converted as an equality constraint. Inequality constraint. Lower bounds also converted as an. Suppose this is the problem. Solve the following LPP using MATLAB. Find maximizes. Maximizes means we have to write it as a minimize. No? Maximizes. Maximizes means we have to convert into minimizes. Minus 3x1, minus 2x2, minus x3. F we have to take minus 3 semicolon, minus 2 semicolon, minus 1. Like this. Only two ways we can solve this problem. This we can treat it as equality constraints, or we can treat it as a lower bounds, and equality constraints are there. How to write this one? 2, 5, 1, 3, 4, 0, x1, x2, x3, 12, 11. Okay. First we solve using this one. Yes. F is equal to minus 3, minus 2, minus 1. Minus 3, minus 2, minus 1. Capital A, null. Small b, null. A equal. Right hand side is our choice. Any A equal. I am writing to. That means we are writing here also we can take capital A, not a problem. So, but this is for equality constants. 2, 5, 1. 2, 2, 5, 1. Semicolon. 3, 4, 0. 3, 4, 0. B equal. Equality. Right hand side. 12, 11. 12 semicolon 11. We call the here. Get what we have to do. This is no lower bounds also have to take, no? Lower bound also have to define. There we can define directly LB. How many variables are there? Zeros of 3 comma 3 rows 1 column. Or 0 semicolon 0 semicolon 0. we have to call the standard I am taking this one. This one. Yeah, what other things are there? This entire thing. Yeah, this is null. Am I correct? Inequalities are not there. A eq, B eq, LB. Okay, A eq, B eq, LB. Capital A null, small b null. Why? Because here, one second, an important part. Okay. 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 ఓకే సార్ 27 నైట్ వెళ్ళిపోదాం మనం 27 నైట్ కల్లా టచ్ ఓకే 27 వెళ్ళిపోదాం మనం అయితే అదే 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 సాయంత్రం వెళ్ళిపోదాం మధ్యాహ్నానికి వెళ్ళిపోవచ్చండి మాకైతే మీరు ఇలా వస్తారా అప్పుడు ఇలా వస్తారా మనం తర్వాత మాట్లాడుకుందామండి అట్లా ప్లాన్ చేసి ఓకే 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 అండి ఓకే మరి అలా చేయండి అయితే మేము అక్కడికి వస్తాం అక్కడ నుంచి మన కార్లో వెళ్ళిపోతాం పెద్ద కార్లో మీ దాంట్లో అందరూ వెళ్ళిపోవచ్చు కదా ప్లాన్ చేసి నేను డ్రైవ్ చేసేస్తాను కదా చూద్దానండి ఇంకా టైం ఉంది కదా 27 1 మంత్ ఉంది ఎగ్జాక్ట్గా కలుస్తాను కదా మనం అందరూ కలుస్తాం కదా ఓకే 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 this is the thing. Okay, so we can solve like this. The same thing we can solve, the same problem we can solve by removing LB also. LB we remove, this we can treat as a matrix. You see this one, I am rewriting the same problem. F is there, A is there, A I am changing. Okay, now you tell me how to write A. Capital A is nothing but -1 0 0 0. Am I correct or not? Here I am changing the same problem, we'll get the same answer. Here A. Capital A is nothing but what? Matrix. You can write directly matrix. -1 0 0 -1 0 0 semicolon 0 -1 0 semicolon 0 0 okay. This is capital A. What is capital B? Null matrix. Am I correct or not? Am I correct or not? Null matrix, right hand. This LB I am writing here. If this is 0 semicolon 0 semicolon 0. Here we have to remove LB. LB I am writing as a AX is less than or equal to B. You will get the same answer. You will get the same answer. The previous answer same as the present answer. The same problem we can solve using. Same problem we can use we can use optimum toolbox. Here, what is A? A is null. Actually, I am taking A is null. Okay, that is better. Later, if you want, you can change. A is null. B is null. I have to change F also. B is null. A equalities are there. The A equalities. Two five one. I am copying this matrix instead of typing. Control C. 11. Control V. Problem something. 11. Copy this matrix. Control V. Lower bounds are there. 0, semicolon, 0, semicolon. I have to change. What is F? Not this one. What is F? Minus 3, minus 2, minus 1. Minus 3, minus 2, minus 1. Minus 3, minus 2, minus 1. Okay, start. The previous answer, same as the previous solution. Okay. $15.667. This is x1, x2. X1, x2. Okay. And this is the way of using. That's I am solving the same problem in different ways. Now, next, suppose the problem contains. Suppose if you want to solve this problem, the next problem it takes a lot of time. No? Am I correct? Equality, inequality constraints. It takes a lot of time. Even the simplex method takes at least 30 to 20 to 30 minutes, 20 to 25 minutes. Now how to solve this one? One equality condition. Shall I use toolbox or shall I use toolbox? Or directly you want command window solution? Toolbox is easy. Now F minimizes, not a problem. F is equal to 1, 2, semicolon 1. F. What is A? Capital A. That is, tell me anybody, what is capital A? What is capital A? Anybody? Anybody? What is capital A? What is capital A for this problem?
Two comma one, sir.
Sir?
So 2 comma 1, na sir.
No. Where is 2? There is no 2, no? 2 comma 1 is not there.
In the main equation, na sir. Yes, sir.
That is A means equality constraints, inequality constraints.
Okay, we need to take from the equations.
Inequality.
Okay.
You take inequality constraint. Tell me the inequality constraint. A means capital A means inequality constraints. Now, what is the inequality constraint? What is the matrix corresponding to inequality constraints?
3, 1.
No. This is equality constraint. 3, 1, 3, 1. These two are inequality constraints. Minus 4. We have to convert it to less than or equal to minus 4 minus 3 semicolon 1, 2. That is A, capital A. Small
Sir,
b.
we should take that equal condition, na sir.
First equality, inequality constraints. First we have to take inequality constraint. These two are the inequality constraints.
Yes, sir.
Minus 4, minus 4x1 minus 3x2 is less than or equal to minus 6. x1 plus 2x2 less than or equal to 4. B is equal to minus 6 semicolon 4. Equality A equality constraints. 3, 1. Only one equation. Right answer B equal. Only 4. 3. Only 10. Matrix 3. We know no issue. Lower bound shall be 0 semicolon 0. X is equal to R x comma f value is equal to improve. That is a solver. Capital A is there, B is there, AQ is there, BEQ is there, comma, lower bounds are there. The number of rows in AQ must be the same as length of BEQ. Okay? The number of rows, only one row. AQ correct only. F2 1 3 correct. Yep, F5 forget. F5 forget. AB I mentioned F in the objective function I forget. In that case it takes this as F, this as G, like that it will take. Okay, F5 forget. Optimization is got terminated. Okay, FAB, BAQ, BEQ, and the solution is 2.4. X1 is 0.6, X2 is 1.2, 2.4. If you want to solve this problem using optimization, optimum toolbox, F is 2, 1. The same thing you have to enter here. Control C. B. Only one constraint is there. Only one equation is there. Three, one, three. One, two, directly. 3, 1, 3. Remove 1, 0. Start. Anything is correct. Okay. First x1 is 0.6, x2 is equal to 1.2. Corresponding solution is 2.400. 400 something. Okay. Like this, we can solve optimization problems using linear programming program. Only I am considering an LPP only. Linear programming problems. If you have any doubts, you can ask. Tomorrow I will start non-linear. This topic. Non-linear constraint optimization. This is a big topic. Tomorrow I will tell. Tomorrow I will complete this optimization problem and I will start graph theory. Day after tomorrow I will close MATLAB. Wednesday I will start LaTeX. That's it. Okay. Any doubts on this topic? LPP? If you have any doubts, you can ask. Any doubts?